Hello everyone. First of all, I would like to grab the opportunity to introduce myself. My name is Bilal Jamal from Lebanon. I'm a telecom engineer and currently working as a senior ERP software engineer. I've enrolled in the course of machine learning and artificial intelligence at Harberton School since Jan 2021. So mainly this course was divided into 4 modules, and that's why we are here today. First of all, this project is my final one in this module at Holberton. Therefore, after covering the majority of concepts and chapters related to AI and machine learning, I will be absolutely delighted to share my information with my peers at Holberton, the engineers, the developers, and you, the audience whose domain is consistent with mine. So to do that, we will shed the light on one of the most important application in AI and HCI system known as speech emotion recognition. Regarding the outline of the project, first of all, we will start by the definition of the term speech emotion recognition. Then we will move to the purpose behind using a speech emotion recognition app. Then we will describe the full architecture used in our project. Moreover, we will talk about the technologies and the pre-processing prerequisites used during implementing this project. We will also have a live technical demo with Python. And then we will talk about the future enhancement that can be applied to our project without forgetting to indicate what are the ethical implications that might be caused by our system. And finally, we will sum up with a short conclusion, and I will be sharing my contact information, my Medium links, in case you have any QAs or you need more clarification regarding the functional and technical part of our project. So first of all, let us define the term SER. As you know, SER refers to speech emotion recognition. It is the act of recognizing the human emotion from speech. It's based on the factor that voice often reflects emotion through tone and pitch. It's similar to the phenomenon used by the animals. You know that the animals always employ their ability to be able to understand human emotion. So SER is very similar to this concept. It's not easy at all. It is tough because emotions are subjective and annotating audio is challenging. So here we have a picture describing the architecture of our project. Here we have a human being that is rendering an audio speech. This speech will be trained and processed through DNN technology known in the machine learning as deep neural network, and the output of the DNN will be one of the emotion generated by this human being. It can be a sad emotion, happy emotion, neutral one, and so on. Now we will move to the purpose behind using speech emotion recognition. First of all, SER improves all AI front-end applications and especially the HCI applications. HCI are the human-computer interactions applications. It will help also the computer agent to be able to comprehend the emotion of the customer in order to pick up the commands given to it. It will enhance also the intelligence of HCI systems through the speaker identification, the speech recognition, and the speech emotion detection. Also, SER can be used in diversified domains such as the CRM, if we're talking about the business domain, the lie detector test, for example, for the security domains, and the feelings of the patient during a visit, for example, this is used in the medicine and the psychology domain. Moving now to the architecture of our project, this is the general block diagram of our application. Here you can see that we have a labeled speech samples buffered into short time blocks. For each block, a spectral amplitude spectrogram was calculated, converted to RGB images, and then passed as an input to the pre-trained CNN. Then, after a relatively short training known as final tuning, trained CNN was ready to recognize the emotions from the streaming speech. This process is very similar to the speech to image conversion. So here in our project, we've used 24 actors as speech sample with a total of 7,356 audio samples having different emotions. Let's now talk about the technologies and other prerequisites needed before being able to implement this project. First of all, we have the Librosa technology. It's a Python library for analyzing audio and music. It has a flatter package layout, a standardized interface and name, a backward compatibility, modular functions, and readable code. Also, we've used JupyterLab, as Pythonians always know. JupyterLab is an open source web-based user interface for Project Jupyter. It has all basic functionalities such as notebooks, terminals, text editors, file browsers, and it supports the usage of third-party extensions. Regarding the dataset used in our project, we've used the RAVDESS dataset. It stands for Rayson Audio Visual Database of Emotional Speech and Song Dataset. It's a shared database. You can download it. It's free. It contains 7,356 files rated by 247 individuals, 10 times on emotion validity and intensity. The size of this dataset is 24.8 gigabytes from 24 actors, but we've lowered the sample rate on all the files so that to be able to be downloaded and processed through our Python code. Also, we've used other libraries such as OS, Globe, Pickle, sklearn, and NumPy. So now we will present a technical demo showing the implementation with Python. The first step is to make the necessary imports. We will import Librosa library, SoundFile, OS, Globe, NumPy, and from the sklearn library, we'll import the train test split, the MLPC classifier, and the accuracy score function. The second step is to define a function that extracts features from a sound file. So this function is named extract feature. It will take 4 parameters, the file name and 3 other features. The first feature is a Boolean parameter. It's called MFCC. It's the mel frequency capture coefficient. So it will represent the short-term power spectrum of the sound. We have the Chroma parameter that pertains to the 12 different pitch classes. And we have the MEL Boolean parameter, which is the max spectrogram frequency. We will use also the soundfile of the file name as command. So it will be automatically closed once we are done. And then we will calculate the sample rate of the file sound. And then again, for each feature of the 3, we will make a call to the corresponding function from the Librosa. It depends on the parameters passed. So if it's MFCC, we will call the feature MFCC. If Chroma, we will call the Chroma feature. And if the MEL, we will call the MEL spectrogram feature. And then we will return the stack array using the NP library. Now we will define a dictionary that will hold the emotions available in the RAVDESS dataset. So here we have all the available emotions. We assign the number as a key and the description of the emotion as a value. And we define another list called observed emotion. These are the emotions that we desire to see. So our function will be implemented to see if the emotion that we're getting from the sound is presented in our observed emotion. So that's why we will implement a new function called load data. This function will take 2 parameters, the local path of the audio file and the relative test size, which is 0.2 initially. We will use also the globe function from the globe module to get all the path names for the sound files in our dataset. The pattern used is C RAVDESS dataset actor. I will show it the pattern. The pattern on my local machine is under the C disk, under RAVDESS data, the directory. And like you see here, there is the actor underscore star slash star dot wave. So the globe module will iterate through all this directory and it will replace the start by 01, 02 till 24 since we have 24 actors, and then we'll iterate through each actor folder showing the audio files that are saved under this directory, and all of the audio files will be processed by this function. So returning back to the function, this function will check if the emotion is in our list of observed emotion. It will get the feature from the extract feature that's already implemented. And then we have two lists, X and Y. X will represent the feature and Y will represent the emotion. And if the emotion is not in the observed emotion, we will continue. So this block of code will not be processed. So we will iterate one and one again until completing all the audio files presented in the directory we have. And at the end of the function, we will return the train test split from the sklearn library, taking the NP array of the features X, Y, also the emotion as parameters, and the test size from this test size, if it's not defined, and a random state of 9 initially. Moreover, we will split the dataset into training and testing sets. So we will call the load data by providing the file path, which is CRAVDESS data and audio files. And with a test size initially of 0.25, this will return a tuple of 4 variables: xtrain, xtest, ytrain, ytest. So x, as we said, is the feature and y is the emotion. So we have a train part of the feature and a test part of the feature, and same for the emotion. Then we will observe the shape of the training and testing dataset. So we will print it in this way. Then we will get the number of features extracted. And the step for calculating the model, we will use the MFCC classifier. It's a multi-layer perceptron classifier. It optimizes the log loss function using the LBFGS or the stochastic gradient descent. So MLP classifier is the function used or the class used from the sklearn library. It will make us get the corresponding model by sending these parameters. These parameters are initially set like that, but you can change it upon what you need. So after getting the model, we will fit and train the model using the model.fit function. It will take the emotion train and the feature train as parameters. We will predict the values of the test data by using the model.predict function. And at the last stage of this implementation, we will calculate the accuracy of the model using the accuracy function of the sklearn library. After trying several inputs and several audio files, we get an accuracy of 71.19%. I will be sharing now the Python code regarding this implementation. We will briefly pass through all the functions or make a small recap of how our code is structured. First of all, as I said, we have the import part. We have then the extract features function, taking into parameters these three sound features, and returning the result of the NP array was calculating the mean based on each feature. This is the emotion contained in our RAVDESS dataset. These are the observed emotion or the emotion that we need to sketch during the implementation. This is the load data function that iterates through the audio files. I will show you how my audio files are stored. So here we have the C disk. Under C disk, we have the RAVDESS data containing all the actors. This is the pattern used: C RAVDESS data, actor underscore star and slash star.wave. So as I told you before, our function will iterate through all the actors folders here, and it will iterate under each actor all the audio files presented. Then, as I told you, we will call the load data, which will return 4 tuples: the features and emotion, the train part, and the test part. We will get the shape of the training and testing dataset. We will get the number of features extracted. We will get the model using the MLP classifier of the sklearn library. We will fit and train the model. We will predict the test set, and at the end we will calculate the accuracy of the project. Okay. After completing the implementation with Python, let us talk about some points or keys that might improve our project. So first of all, our main priority is to increase the accuracy of the model to reach a percentage of 80 and above. The second part is to train the model with more emotion types other than the one presented now in the RAVDESS dataset. The third one is to figure out a way to clear the random silence from the audio clip. We don't know if the silence in an audio file can be considered as a neutral emotion or a normal emotion, so we need to figure out a way to clear this silence. We can explore other acoustic features of the sound data to check their applicability in the domain of SER. We can add some data augmentation techniques to the voice, or like time shifting, like speeding up or slowing down the audio, so that to see if our SER will still accurate and can notice the correct emotion. Also, we can apply this SER in other foreign languages such as Chinese, Japanese, Dutch, and etc. Also, as any AI application, this project might impose some ethical implications. So, first of all, this project might cross the privacy of the person. Someone maybe doesn't want his voice to be recorded, and if he doesn't any problem with the recording, maybe the person doesn't want their emotion to be recognized. So this is the first drawback or first ethical implication with the SER. Also, this app might replace any agent presented in the customer service industry. Is it something positive or negative? I think human being should always be presented nowadays, especially in the customer service industry. So why replacing the job of a human being with an AI app? And the third drawback that might be affected by our SER is the RAVDESS dataset that we considered. It is enough to cover the entire range of emotions for different culture, or we need to find another database or find another people talking in other foreign languages. So these are mainly the ethical implications that might be caused by our project. So to sum up our presentation, as we said, SER is a key front-end application of AI. It's mostly used in the HCI applications. So a reminder, HCI applications are the human-computer interactions apps. We learned through our presentation and technical demo today how to recognize emotions from speech. We recognized emotion using the MLP classifier from the sklearn library. We've also made the use of the SoundFile library to read the sound file and the Librosa library to extract the features from it. And the model has delivered an accuracy of 71.19%. So, as I told you at the beginning of my presentation, I will be sharing my social presence on GitHub, the LinkedIn profile, my contact email. Also, if you want to know more information regarding the SER application, I've already wrote an article, a full article describing step by step the SER architecture, the functionality, the Python demo that we saw today. So feel free to ask any questions, feel free to comment or contact me on my personal email. I will be here to support at any time. So thank you for your time, and I hope that I added some extra addition to your knowledge in the domain of machine learning and artificial intelligence. Thank you guys, and see you in other presentations.